Good day everyone, this is your Kasi Kids L. Luis and welcome to the 5-episode series of Group 7. Today, we are on the second episode of our 5-episode series of Laplace Transform of Function in differential equation. For this episode, we would now focus on the transform of e raised to 80 theorem. But before we solve this Laplace transform of functions, let us first see how these things work.
So for the next part of the table of Laplace transform of elementary functions, it states that the Laplace of e raised to the power of at is 1 over s minus a, where a is any whole number.
This definition encourages us young solver to solve Laplace problems in theorem in much more easier way. So much for that. Now let us proceed talking about Laplace transform of function, highlighting the transform of e raised to 80 theorem. Let's see this one.
Good day everyone, my name is Jansel Grace B. Mombellia. So today we're going to discuss about the Laplace transform of e raised to 80. And now, let us solve for this example. The Laplace transform of e raised to 80 is 1 over s minus a. For example, find the Laplace transform of e raised to 3t plus 6e raised to 2t. So all we need to do is to substitute the given value of a here at the denominator. So 1 over s minus 3 plus, since e has a coefficient of 6, then we will put it here, and s minus 2. So if we will simplify this, we will get their LCD, which is s minus 3 times s minus 2, and then cross multiply. 1 times s minus 2 is s minus 2, and 6 times s minus 3 is 6s minus 18, and then we will combine like terms. S plus 6s is 7s, then negative 2 plus negative 18 is negative 20 over s minus 3 times s minus 2. So this is the final answer.
If you truly observe how these things work, you would eventually see how convenient this type of solving Laplace transform, as you could only see and check using the table. Let us see another example.
Hello, my name is Kentlite L. Manapos, and today I'm gonna show you an example on how to solve a Laplace transform using the function of e to the 80 times f of t. So the problem here is we have to find the Laplace transform of e to the negative 3t sine 5t. So the formula is, here we have the Laplace transform in the exponential function to the 80. So a here is a real number, so it's like e to the 5t, e to the 3t times f of t. So what we're gonna do here is we have to drop the e, so we'll get f of t. And when we do that, we'll do a shift. So the shift takes to s minus a. So we'll proceed to the problem. So here we have to define the Laplace transform of e to the negative 3t sine 5t. So again, we have the exponential, so we have to drop it. So we'll get sine 5t. So the shift is on the outside because this is a function of s. So the s is s to s plus 3. So the a here is negative 3, so we'll get s plus 3 because s minus negative 3 is s plus 3. And sine 5t, it's like sine bt. So sine bt is equal to b over s squared plus b squared. So here we'll get 5 over s squared plus 25. And then we'll replace the s with s plus 3, so we'll get 5 over s plus 3 quantity squared plus 25. So this is the answer. So basically, we have to drop the e and replace it with a shift.
In this episode, we were highly taught how the table of functions works using e raised to at theorem. Hopefully, you have gained the idea of this concept through some examples. That would be for now. Let us continue talking about this topic on the next episode for exam examples. This has been your Kasi Kids Eloise, and see you on the next vlog.